All right, Packet Nation, we're going to talk about a TCP Dup ACK, what it is, why it matters, and how to look at it in Wireshark. Wanted to go back to basics on some of these points that are covered in the Wireshark Certified Analyst exam. You can find those on the objectives, links in the description down below. By the way, this is the 1-year anniversary of the Wireshark Certified Analyst, so if you'd like to get some more training on it, go ahead and check out my complete course in the link down below. Also, I got a bit of a discount for you down there. Okay, so what is a TCP Dup ACK? Well, just put real simply, it's a duplicate TCP acknowledgement. But why does it happen? Go ahead and pull down the packet capture in the description down below and follow along. All right, so I got my PCAP up, and if you notice over here on the right, you can see some black lines and red letters. You also see that just in the packet summary up here. Right away, we can see some Dup ACKs, previous segment not captured, out of order. But what are these Dup ACKs and why do I care? Well, first, if I come up, one thing I'm going to do right away is when I'm doing this kind of analysis, it's important that I look at my columns. And here I can see I got my delta time. If you want to check out how to do that, you can look at the video just up here, show you how to do this and the coloring and some of the basic things that you see in my Wireshark profile. But here we can see a TCP connection gets set up. The client goes and does a request. It gets this file. Server starts to come back with some of the stuff, some of the details, and then we start to see some ACKs. Well, when I'm doing my TCP analysis, I want to add a couple of fields. So I'm just going to come down here to my sequence number, and I'm going to look at relative sequence number, going to right click, add that as a column. And also I'm going to take at my acknowledgement number, relative ACK number, and also another way that I could get it upstairs, just I'm dragging and dropping, and I'm just dropping this right next to sequence number. Gonna flip those around. Now I am, just because I'm a real estate person, I like to just see only what's necessary, so I'm just gonna do SEQ, and I just did a right click edit column. So that just condenses that title up there. Same thing with ACK number, gonna right click edit column. Just gonna say ACK number, and I'm good. Okay, so I like to see those to help to understand what a Dup ACK is. All right, so I see my data going back and forth, and right here, this is the first time that I see previous segment not captured. Now, this is where the Wireshark dissector, the TCP dissector, is like looking at all of the information and going, whoa, wait a second, we saw a gap here. Now, what did it see? Well, the most recent thing that I saw from the opposite side, let's look at the direction of traffic here, 186.15, 230, 25. So last time I heard from a packet in this direction, it was the sequence number was 7301 and it was sending 1718 total bytes of length. Let's take a look at the actual TCP length though. The segment length was 664. In fact, I'm going to take this, just a little sidebar for the packet people. I'm going to just take this segment length, drag that upstairs, and remove temporarily my regular length. I just right clicked on that column header. Now I can see the TCP payload size, which matters for sequence numbers. This is how much the sequence number should increase on the next packet. All right, so 7301 was the last one that I saw. This packet is 664. So in the opposite direction, the next thing that I should see is the next sequence number, which is 7965. This is the next thing that I should see from that direction, but I don't. I see 12345. In fact, I'm just going to quickly bring up a calculator, and I'm going to use this number, this where I'm at, so 12345, 12345, 12345, that's interesting. Okay, and I'm going to subtract where I should have been, which is 7965. So 7965. All right, if I subtract that. Now, 4380 is an interesting number because if I look at the total segments that I'm sending, or all of these larger packets, 1460 are the MSSs that are being sent. So if I go ahead and take a stab and divide that by 1460, sure enough, I can see that I'm missing 3 full packets. All right, so what that means is that between this most recent packet that I saw and the next one that we observed, 3 full MSSs went missing from the server toward me. So that's packet loss. And 3 packets went missing. Now, how does the client indicate this to the server? This gap that it observes. The next one, keep in mind, the next one that I want to see is 7965 from that server. So the client, what it does is, it just had already sent this get out to the server. So from its side, the sequence number is 391 plus 350. In the opposite direction, we can see the server came back with 741. So the server got this get, the server likely realized, hey, those packets went missing that I sent, so let me just start to deal with those down here. But the client, when it sees this packet come, this 1460, the client goes, whoa, 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 wait a second. Why did you jump all the way to 1235? You should have been at 7965. This is a duplicate acknowledgement because 7965 we've already seen before. Go up to packet 14. This is a duplicate of packet 14. Now there's a few things that qualify it to be an actual Dup ACK. First, we're duplicating the ACK number. Also, it's an empty packet, so there's no payload. We're not sending data out to the server. So it's empty, the Dup ACK is there, and the window size on the receiver, if I take a look at packet 14, look at my window size, the calculator is up to 17,520. And if I come down here and take a look at the Dup ACK, it's also 17,520. So those are the different things that are met. The window size didn't change. We're not ACKing any new information. We're duplicating the previous ACK number, and we're not sending anything. It's an empty packet. Now, if you ever forget stuff like that, there's a very useful feature on the wireshark.org site, and that is in our user guide. You can go to the TCP analysis under advanced topics. I'm going to link this down below. And what I like about this is something I keep bookmarked so that when I'm digging through Wireshark and I see things like TCP Dup ACK, it tells me what are the things that it looks for in order to qualify something as a duplicate acknowledgement. All right, so segment size is 0. The window size is non-zero or hasn't changed. The next expected sequence number and last seen ACK number are non-zero, and the SYN, FIN, and reset are not set. So this isn't something that happens at the very beginning of a connection, but it's likely in flight. And one of the things that's indicated by a Dup ACK is we have some packet loss, and the client is trying to help the server recover from that. This is basically a heads up to the server. Hey, server, I had to duplicate that previous ACK number. Even though you sent new information, I'm ACKing the most recent one that I'm on. That's the one that I want to see. Now, while we're here, let's take a look at this server and how it responds. So these Dup ACKs go out, and notice Wireshark is tagging these as TCP out of orders, but actually these are retransmissions. If you come down here, you can see 7965. That's the one, that's the sequence number that we've been waiting for. So this is the first packet that got lost, the second packet that got lost, the third packet that got lost, and then the receiver can advance its sequence number all the way up to 14406, and we are good to go. We've seen all the sequence numbers. Now, fuel for another conversation. A lot of times in duplicate acknowledgements, you also see something called selective acknowledgement blocks, SACK blocks. So we'll get to those on another video, packet people, but for now, remember what a TCP Dup ACK is. Just that. It's a duplicate ACK of a previous ACK that we've already seen. It has no payload. It usually doesn't happen very beginning in the TCP conversation, and typically it's an indicator of packet loss. All right, there was your WCA quick tip. Hope all's well in the packet sphere. See you guys later.